Right, so this is Geometry Lesson 724, fourth lesson in Chapter 7 about quadrilaterals. And we're just going to do a couple of proofs today for this lesson. All right, so our first proof is proving that an isosceles triangle has two congruent base angles. And so we can assume that two sides in the isosceles triangle are congruent. So side AB and BC. And we're going to split the triangle. I'm going to split it in half. I'm going to make what's called an auxiliary line down the middle. It's not the greatest line. Let me try again. It's a little bit better. So this is going to split it in half. And so I'm just going to make a note that BD, oh gosh, not BB, BD splits triangle ABC in half. So point D is the midpoint of AC. All right, and so now I'm going to start my proof with the given AB is congruent to BC. Circle that and write given underneath as our reason. And then I can say that AD is equal to CD. And that reason is going to be midpoint, definition of midpoint. And finally, we know that BD is equal to itself. And the reason that something is equal to itself, we always use a reflexive property. All right, so now we can say that triangle ABD is congruent to triangle BCD by side, side, side. And that helps us prove that our base angles are equal. Since every part of the triangle is equal, we can now say that angle A is congruent to angle C. Those base angles are equal. And the reason we put underneath that is CPC, TC. Corresponding parts of congruent triangles are congruent. All right, in our second proof, we are given a rhombus. Remember that the definition of a rhombus is that all sides are equal. So I'm going to go ahead and mark this. AB equals BC and DC and AD. We are trying to prove that the diagonal of a rhombus bisects the angles. So we are trying to prove that ABD, so this angle right here, is equal to this angle right here. That should be pretty easy. We want to prove that triangles are congruent, and then we can prove that those two angles are the same. All right, so we'll go ahead and start this proof off. I'm just going to make a big bubble saying that all the sides are congruent. Circle all that. The reason we know the definition of a rhombus is that all sides are equal. Okay, so remember that one wasn't given to us. We had to, sorry about that guys, my phone went off and my dog started barking. So we're just gonna keep moving forward. So all sides in the rhombus are congruent to each other, and that's the definition of a rhombus. not given to us. We had to figure that out for ourselves. And then the third side that is equal is that side in the middle, overlapping BD. So BD is equal to itself. And again, our reason is the reflexive property. All right, and then we can say that triangle, and I'm going to label it so that B is equal to itself. So I'm going to label this A, B, D, and I'm going to label the other one C, B, D, so that both the B's are in the middle. All right, and these are congruent, again, side, side, side. I always think that's the easiest congruence theorem to prove. I always like using side, side, side. All right, and now we can say that angle ABD is congruent to, oops, not triangle, just angle. Angle CBD. By CPC/TC. So corresponding parts of congruent triangles are always congruent to each other. All right, and those are our two proofs.